Hello everyone, welcome to my programming club. Today we will be solving another daily Leetcode challenge, and the challenge name is painting walls. So the challenge statement goes like this. You are given a zero indexed integer array and which is represented by cost and time. Basically two integer zero indexed arrays are given to you, representing the cost and the time that it will take to paint n different walls respectively. There are two painters that you have that are available for you. One is the paid painter, another one is the free painter. So the paid painter paints the ayat wall in time I units and takes cost I units of money. Okay, and the free painter will paint any wall in 1 unit of time at zero cost. It will not He will not charge you anything and will paint any wall in 1 unit of time. But the free painter can only be used. There is a constraint if the paid painter is already occupied. Okay. Return the minimum amount of the money required to paint n walls. So how we will be solving this problem? First of all, let's have a look at the constraints. So the length of the cost array will be of order 500. So in total 500 walls can be there. Okay, and first of all, the very first approach that may come to your mind is a greedy approach, but greedy solution will not be possible here. You might think that you can greedily give painter one or say paid painter the jobs which cost less and take more time. In this way, he will be occupied most of the times. And free painter can paint the more expensive walls, and free painter can paint more expensive walls. Okay, but this greedy approach will not necessarily work. We have to try out all the combinations. Basically, to try out won't work. This greedy approach won't work. Why it won't work? Because it is very difficult to arrive at a greedy solution which will optimally solve this problem. So if we look at the constraints, the cost total number of walls will be of order 500 number of walls Okay, and for each wall you will be having two options. Give it to paid painter or give to free painter. Okay, these two options will be there for each wall. So let's say the number of walls is n, then in total 2 into 2 into, it will continue like this, n options. So 2 raised to power n options will be there, combinations will be there. Okay, and since 2 raised to power 500 will be very much greater than 10 raised to power 8 operations, this is a limit on the number of operations, that is that, and if the number of operations in your program or solution exceeds or become equal to this number of operations, then you will get a TLE, time limit exceeded. So we have to optimize this approach. Optimize, brute force approach. Now consider the below scenario. Let's say there are n walls and some sequence is like this. First, let's denote the paid painter. Sorry, paid painter and free painter. 0 and let's call it 1 and 2. So there can be a sequence like this: 1 to 1, 2 to 2, 2. And there can be another sequence like this: 1 to 1, 1, 1, 1. So in this, let's call this combination 1. Let's call this combination 2. As you can see, this part is common in both of these. So this is, for this part, calculations are being done twice. We have to avoid extra work. Uh, there is another observation. Solution of n walls will depend upon sub-solutions of n minus 1, n minus 2, n minus 3, and so on. Okay. So what selections you have made previously matter? You have made previously. Contribute to present solution. Okay, and these subproblems solution can be combined to form solution for bigger problem. Okay, so this is observation number 2 and previous was observation number 1. So this particular property is called overlapping subproblems. As you can see, this subproblem is existing in both of the combinations. Okay, those of you who are new to this property, I will be providing a link for article describing this. And the following property was optimal substructure. It is it is nothing but uh, your smaller subproblems solution can be combined to form solution for bigger subproblem. Okay, I will also be providing link for this property also. So when these two conditions are satisfied, we can apply dynamic programming. Okay, those of you who are new to dynamic programming, I will be providing a link for this one also. So how we will be solving the approach with the dynamic programming? Let's say you decide to give ith wall to paid painter to paint. Then in that time, free painter can paint let me check the name of the array times ith time walls, the number of walls. So total number of walls painted will be time I plus 1. Okay, and it will cost us cost of element at the cost element in the cost array at the ith index. Okay, this is the observation that will help us to apply dynamic programming here. So for each wall, consider two scenarios. Either it can be assigned to first painter or paid painter, or not assigned to paid painter and assigned to pre-painter. Based upon our choices, the cost of painting remaining walls will vary. Okay, so we will take contributions of this decision to all the remaining walls. All remaining walls. Okay, now let's solve the problem. It is to be mentioned that cost I is given at max 10 raised to power 6. So if we multiply 10 raised to power 6 with 500, it will be something like 5 into 10 raised to power 8. Okay, so you can take it to be 5 into 10 raised to power 8 plus 1, your answer initially. So without further delay, let's implement the solution. Let's change the programming language. Okay, size will be the size of or the number of walls of your cost array, or the number of walls you can say. So we will declare a, okay, and here we can store the results to avoid recalculations. Avoid extra work. Okay, so here we will declare a vector. Let's call it minimum cost to paint wall. Okay, and it will be of size plus 1 since it's a zero based indexing, and initially all the values will be set to, instead of this particular number, we can use infinity also. Infinity means maximum integer value. Okay, I think it should be fine. And since if there are no walls, so the minimum cost to paint wall zero walls will be 0. Okay, and then walls, number of walls will be ranging from, or you can use index also. Index will be ranging from 0 to n. Okay, where n is the size of the given. Pardon, please. There was some technical glitch. And for each value, we'll consider whether we can, whether paid painter can take this wall or not. For each wall, you will consider whether paid painter can take up this wall or not, and carry out the effect of this decision on the remaining walls. Okay, so the remaining number of walls will be ranging from remaining walls or an index. Instead of index, you can call it wall index. Okay, it will be a more appropriate term. Remaining walls will be ranging from n to 0, and here is the size greater than 0, since 0 is already accounted for. Painting 0 walls will cost us 0. Okay, and yeah, then remaining walls will be decremented. Okay, and you will take the contributions in to remaining walls. Take contributions of your choice of either selecting or not selecting current wall for painter, paid painter. Okay, so your minimum cost to paint wall to remaining wall will be affected from two decisions, which will be minimum of either you will skip the current wall to be assigned to painter, paid painter. In that case, your minimum cost to paint wall, remaining number of walls will be as it is, or you can assign current wall to paid painter. In that case, minimum cost to paint remaining wall, this cost, uh, will be updated to minimum cost to paint walls that are now remaining, which will be remaining wall minus this value. Which value I am talking about? This value. Time it will take to paint the wall with wall index, and so in this time these number of walls will be painted by the free painter and one wall will be painted by the paid painter. Okay. I should write this for explanation also. Number of walls painted by a free painter in the time which paid painter paints one wall. Okay. Plus cost to paint current wall, which will be wall index, wall at index, wall index. So this will be the equation, or say the change of states that will help us to solve this particular problem, and at last we will be returning minimum cost to paint walls equal to SZ. Let's try to submit for the sample test cases. Let's see whether it's getting accepted or not. There is some compilation error. Okay, we forgot to write 2 here, I think. There is some typing mistake again. Let's try. It usually happens when you give such a big name, some typing mistake occurs. Yeah, for the minimum, we shouldn't have given semicolon here, we should have given it here. These are some syntactual and typing mistakes. Rest, I think the solution should be fine. Okay, we should have been returning it from here. So it's giving sign integer overflow. Let's try to resolve this bug. So I have done 2 changes here. This value can also be negative in case the number of this number approaches to a negative number, so I have taken max of 0 volts and this number. So another change that I have done here is, instead of max integer value, I have taken this value. Okay, value that we discussed can be maximum cost. And let's try to submit for the sample test cases. As you can see, for sample test cases it's getting accepted. Let's try to submit for final evaluation. As you can see, it's getting accepted. So this will be our approach. If you are still having any doubts in this approach, please feel free to ask them in the comment section. I will be more than happy to answer them. And we can easily convert this one into Java also. Okay, instead of this E, it will be 500000000. Okay, 8 10 raised to power 8, and instead of vector it will be integer array. Rest all things will be fine. And it will be arrays dot fill. We will be filling this minimum cost to paint array. Okay, and a new integer array will be declared here. Rest I think should be fine. And instead of that max, you should be writing math.max, and here also math.min. Let's try to submit for sample test case. Okay, it should be arrays.fill. As you can see, it's getting accepted for sample test cases. Submitting for final evaluation. Yeah, it's getting accepted for final evaluation also. So the code will be available in C++, Java, and I will try to implement it in Python 3 also. So thanks for watching. Thanks.